Let's start off by looking at some expressions and formulas. For some terminology here, just so we're all on the same page, variables are going to be the letters that represent numbers. All right? So we have variables that you might be used to, like x or n. We use them a lot of time in equations and expressions, and they're very direct. They're letters, and they're meant to represent numbers, but we just don't know what those numbers are. We have other letters that can be used, like theta and alpha and beta, and these are all Greek letters. They're still letters, and they're still used to represent numbers, which makes them all variables. We have other letters, like pi and e, and these letters are used to represent numbers, but they're numbers that we do know. We know that pi is 3.1415926, and e is 2.7182818, blah, blah, blah. Now, when it comes to expressions are going to be any collections of numbers, variables, and operations. An algebraic expression is going to be a specific expression that has variables in it, which means regular old expressions maybe don't. Something like 2 is an expression, or 2 plus 4 is also an expression. Collections of just numbers and operations. Algebraic expressions then are going to be when we have those variables tossed in there too, like 2n plus 4 or 3x divided by 7 pi. Here we have our collection of numbers, variables, and our operation being the fraction bar or division. To quickly review something that you should have learned in Algebra 1, if we want to simplify any sort of expression, we're going to have to use our order of operations. A common little mnemonic device that people tell themselves is PEDMAS, to help us remember that our first step is any grouping symbols, parentheses. But grouping symbols are more than just parentheses. They could also be things like square brackets, or even a square root symbol or a fraction bar. Could all be grouping symbols. But after you simplify what's all grouped together, the next thing is to simplify any exponents, powers. After that, it's multiplication and division, and you finish up by adding and subtracting. So if we want to evaluate this algebraic expression, m plus the quantity p minus 1 squared, when m is 3 and p is negative 4, our very first step is going to be to substitute those values in for the variables. So we have m plus p minus 1 squared. And we want to put their values in there. It says that m is 3 and p is negative 4. So when we simplify, the way I have it written now has entirely too many grouping symbols. For instance, this 3 right here. What's inside of that grouping symbol is already simplified, so I'll just leave that as 3. And same thing when I get to this negative 4 right here. Inside those squares brackets, it's simplified, it's negative 4. But inside the parentheses, it's not simplified yet. So next, I'm going to simplify this negative 4 minus 1. So everything else stays the same. We'll still have 3 plus, and that thing's going to be squared. However, when we simplify negative 4 minus 1, we get negative 5. Now that everything is simplified inside of all of the grouping symbols, we move on to our next step, which is going to be the exponents. And here, our only exponent is going to be this second power. So we need to take negative 5 to the second power. When we do that, the 3 plus all stays the same. But remember, negative 5 to the second means taking negative 5 and multiplying it by itself. Negative times negative becomes positive 25. We don't have any multiplication or division, so we don't have to do that. And we finish up by adding and subtracting. And 3 plus 25, of course, is 28. Let's try another one. Let's evaluate a plus b squared times the quantity b minus a, when a is 5, b is negative 3.2. So first thing, of course, is to substitute all the values in. So we have a being 5 plus b squared, and b is at negative 3.2, and that's getting multiplied by b minus a. So b is the negative 3.2, and we'll subtract a, which is at 5. Now that everything's plugged in, we go through our order of operations and simplify what's in the parentheses first. We have a couple of grouping symbols, the parentheses right here, this negative 3.2, that's already simplified, but this negative 3.2 minus 5 is not. So I'm going to leave everything the same, this negative 3.2 being squared, and just simplify what's in this last set of parentheses. Negative 3.2 minus 5 is negative 8.2. Now that all the parentheses are simplified, we move on to the exponents. Our only exponent being negative 3.2 squared. So we leave everything the same, 5 plus. This is where we're going to do negative 3.2 squared, and then we'll multiply it by negative 8.2. Now, I know negative times negative is going to be positive. I know 3 squared is 9, and 4 squared is 16, so my answer's got to be somewhere in between there. But maybe I don't feel very confident multiplying 3.2 times 3.2 in my head, and that's okay. So you use your calculator and multiply that out and find out 3.2 times 3.2 is 10.24. Our next step is to look for any multiplying or dividing, and our expression is 5 plus parentheses 10.24 parentheses negative 8.2. And when we have two numbers just sitting next to each other in those parentheses like that, that implies that these two are going to be multiplied together. So we're going to leave that 5 plus, and now go to the calculator and multiply 10.24 times negative 8.2. And we get negative 83.968. It's not polite to have an addition and a negative right next to each other, so we separate them with the parentheses again. However, we're just going to add a negative number. So adding a negative is the same as subtracting, and 5 minus 83 is going to give us an answer of negative 78.968. Let's try one more expression, and this one's pretty big, pretty gnarly looking. We got a lot of variables, but we want to evaluate x to the fourth minus 3wy over the quantity y to the third plus 2w. When w is 4, x is negative 3, and y is negative 5. Our steps are still the same, where first thing we want to do is to substitute all the values into our expression. So when we have x to the fourth, x is negative 3. I want to take that entire number to the fourth minus 3 times w times y, where w is 4 and y is negative 5. All of that is going to be divided by y to the third plus 2w, where y is negative 5 and w is 4. So this is an example of an expression that has a lot that's going on. And we need to kind of make some inferences here. For instance, because we have this fraction bar, what we need to do is to simplify the entire numerator and the entire denominator before we can do any of that division. That's how the fraction bar ends up acting like a grouping symbol, even though it's not a parenthesis. So let's take a look at the numerator. Inside the numerator, we have an exponent right here, negative 3 to the fourth, and 3 numbers that are being multiplied together. Let's deal with the exponent first. Then negative 3 to the fourth means taking negative 3 times negative 3 times negative 3 times negative 3. One that you could do in your head or in your calculator. Taking a negative to an even power makes it positive. 3 times 3 is 9. Another 3 times 3 is another 9. And 9 times 9 then would be 81. After that, in the numerator, we still have negative 3 times 4 times negative 5. In our denominator, we also have a power that we can deal with, that exponent, negative 5 to the third. And when we do negative 5 times negative 5 times negative 5, a negative to an odd power would be negative. And 5 times 5 times 5 is 125. After that, plus 2 times 4. As we continue with our fraction, take the numerator and the denominator separately. In our numerator, we have our multiplication happening here. So we're still left with that 81. And we have to do negative 3 times 4 times negative 5. And the negative times negative will make things positive, so we'll put a plus in there. 3 times 4 is 12, and 12 times 5 is 60. In our denominator, we start off with that negative 125, and we have plus 2 times 4. 2 times 4 being 8. We still don't have everything simplified. We still have a numerator and denominator to deal with. In the numerator, 81 plus 60 is going to be 141. And in the denominator, negative 125 plus 8 is the same as the opposite of 125 minus 8. So 125 minus 8 is 117. Now you may be looking at this thinking, oh, looks done to me. 141 over 117 probably can't be simplified. But you'd be wrong. We do have to look to see if there are any common factors that we can cancel out. Now, there is a way to tell that they do have this common factor. If you look at the individual digits in the numerator, 1, 4, and 1, when you add up 1 plus 4 plus 1, you get 6. And when we do that same thing in the denominator, 1 plus 7, that makes 9. Since both 6 and 9 are divisible by 3, what that means is both 141 and 117 have 3 as a factor. In fact, if you added those digits together and they were both multiples of 9, then that would mean that both of them have 9 as a common factor. Now that only works for factors of 3 and 9, but it's a nice little trick to know. We still need to figure out what the other ones are, what their other factors are. So 141 divided by 3 would be 47. And negative 117 divided by 3 would be negative 39. So after we cancel those common factors, we get our final simplified fraction be negative 47 over 39. Lastly, let's deal with the formula. A formula is just going to be a mathematical statement that expresses the relationship between certain quantities. In this example, we have the formula for the volume of a cone being V equals 1/3 pi r squared h. Can be used to approximate the volume of a tornado. We want to find the approximate volume of this tornado. Now, whenever you're dealing with a word problem, if you look through the word problem and see a formula sitting there, the very first thing you should do is take that thing out. Because we're definitely going to need it. And in fact, we are told the formula finds the volume of a cone, and we can use it to approximate the volume of this tornado because it looks like a cone. When we want to find that volume, we don't know the volume, so we don't have a value for V. Otherwise, we want to substitute numbers everywhere we can. We know that pi is 3.141. The radius is going to get squared, and that'll be multiplied by the height. When we move over to the picture, the radius is the distance from the center to the edge of the base. In this case, that would be 75 meters. And the height of the cone is given right here as 225 meters. To evaluate this formula, we can use our order of operations. It looks like everything is multiplication, but we do have this one spot in here where we do have an exponent to deal with. So let's multiply that out first. We'll leave everything else the same. 1/3 times 3.141. And over here we'll have 225 meters. Now when we take 75 times 75, we get 5,625. And meters times meters is going to be meters squared. At this point, the last thing to do is to multiply it all out, and I would definitely use the calculator to do that. 1/3 times 3.14 times 5,625 times 225 is approximately equal to 1,325,109. Now, your calculator probably gives you a 0.375, and that's what we're saying approximately, because when we're multiplying by 1/3 or dividing by 3, we know that that decimal is going to go on and on and on forever. We also have units that go along with this problem. Within the context of this problem, everything was a measurement. And I say this a lot, that in word problems, numbers aren't numbers, they're measurements. So we have this 1.3 million number, but that's not a measurement until we include units. So we also need to deal with this meters squared times meters. And that'll just give us meters to the 3rd power. So we'd say that the approximate volume is the 1,325,109 cubic meters.